Hello again from Skip, Victor Echo 6 Bravo Golf Tango. Got another little project here for your entertainment. So between fixing old pieces of test gear and building some metal projects in the garage, I was trying to get back to the 10 gigahertz project, and one of them was to build up a different type of, well, we'll call it a controller like I use for my big dish for the much smaller dish. Well, I got mainly the Visual Basic program that I wanted to rework, and I've been wanting to redo it even for this, for the big 21-foot dish also. So this is where this story's heading. As I've shown in my other videos, this is my main control screen, we'll call it, for my dish. It's a Visual Basic program I like to build, and I've been adding things to it just for years and years and years, and it's actually got kind of cluttered. And I've been wanting to redo it for a long time. So this one here, I mean, it works, but the problem I had before with the dish when I get up in 9 centimeters and 6 centimeters was the control system works on a feedback from the encoders. And the resolution is only 0.1 of a degree. And when I'm using the noise meter to peak on things, I can go right past the peak because it's always going to the next 0.1 of a degree. So I needed something to go between. And I've been racking my brain on and off for, a year or so anyways, just how to do this. And I've come up with a cunning plan. So this is where it started, was to scrap this version of a control system and build a new Visual Basic program. I do wind up using a lot of the same bits and pieces of code, but it's all in all, it's a new one. Okay, first off, I'm going to give you a little rundown on how this thing works. I've described it before, but this will make a little more sense on just how I accomplish this. I've shown you this block diagram before in previous videos. It's how it all works. It's kind of convoluted, so I've drawn something simpler just to deal with the part we're going to work with here to get this working properly. This is a much simpler, I will say, description how this works. It's a closed loop control system. I guess I must have picked this up working in the oil field and hydraulic systems. I don't know, but anyways, on the left there you can see the Visual Basic Human Interface. Well, that's the computer. That's where the VB program is, and that's how I control things or tell it what to do. So serial data is sent from it, and both azimuth and elevation are combined in one packet of data. We'll say. It goes into a serial data divider, or a splitter, and both pieces of information, still combined, goes straight across to the elevation box, and the other part of the splitter, one goes up to the azimuth box. And this is how things get a little interesting. These two little circuits, they're both PICs, little 8-pin bodies. They look at the data coming in, and they're looking for a $6 and a $5. That's the two headers that determine if it's going to use it as azimuth or use it for elevation. And it's in there where it strips the elevation and azimuth data off the combined information or data coming in and sends along just only the azimuth over to the main PIC control, and now in the other one to the main elevation control, the main PIC part of the circuit. From there, of course, the information is gathered, compared, and pulse width modulation signal is sent out to the motor. The motor turns the dish, of course, and the shaft is connected to an incremental encoder, and the encoder is creating pulses, and it's fed back up into the PIC circuit, which gives a display there of the actual position. But that data then is converted to serial information and is sent back to the Visual Basic Human Interface, the computer, and displays it on there also. So you can see where there's a closed loop circuit here on the right hand side. I'm just showing the elevation part because that's all we need to contend with. The azimuth up above is exactly the same. So it's in there because of the incremental encoder gives me a resolution of only 0.1 degrees, so I can't go any finer. So I go from, say, 10.1 to 10.2, but I can't go 10.15. And there's a problem. Up in the higher bands, I go right past the peak of the moon noise or the sun noise or whatever I'm trying to track, or or just peek on with a noise meter to see what's going on. So that was the issue. So the cunning plan I had was to have some kind of manual control over the motor outside of the loop, yet still through the Visual Basic program. I could sit there and just tweak it back and forth and have it move in miniature movements, small increments of movements, and the loop circuit would just sit on the side and do nothing. So this is how it's done. Many years ago when I was building this thing, and I made them little buffer circuits, I call them, to split the data for the azimuth elevation. I also built in external outputs for external controls. So right away I had a light bulb go off. I'm already using some of those controls for the high-speed select from the Visual Basic program, so it was just a matter of modifying that. I didn't want to have to redo the hardware. I didn't want to build new boards and stuff, so it was perfect. So I had a plan, had an idea. First thing I had to do was build a new Visual Basic program. I started this quite a while ago, but I'm just finally getting it finished now. So this is a story. So like I said, I've been working on this on and off for quite a while, and it actually started probably a good year before this for the 10 gigahertz offset feed dish control. So I started building more of a test Visual Basic program just to see if I could get this new idea to work. And this is the beginning of it. And like I say, this is probably a year ago now. The little PIC that buffers the incoming serial data and gives me the external controls on the simulator here, it sits on a separate board. So I pulled that chip out and built a plug with an external cable that would go over to this larger evaluation board, so I could, work on the code for the PIC itself. Back then I was using this old screw jack arm with this simulated elevation actuator, if you want to call it that, for testing this, but it proved it would work. So now jump ahead a year and we'll jump to how we built the actual program for the 21-foot dish. I'll go back to this project. First thing I did was scrap that old screw jack, and if you recognize this is the elevation drive for the offset feed dish. So I figured, well, when you use it for that, might as well have it in there. Plus, it takes up a lot less space, and it just runs a lot better than that screw jack thing. So this is tied into the simulation board, and things were being tested. I guess the biggest, I won't say hassle, but the biggest problem I had to do was I had it built on that test VB program for one side for elevation. We'll say, well, I had to copy it into the azimuth side. And there's, issues with that. You cut and paste, you run into issues and things that don't want to work right. So it's a matter of just testing and playing around. And I came up with this. Anyways, eventually this is almost the program finished. So I slowly go through one bit at a time and make sure the buttons are doing what they're supposed to do. And, well, here's one snag. Whoops, that's not right. The one high-speed button on the azimuth should be turning the elevation on and off. But hey, that's what you get. Then, of course, there's the good old compile error messages. So we flogged through it and slowly got things figured out. It took some doing, though. Okay, kind of got ahead of myself here. So the VB data that's sent out goes into these two buffer PICs, and this is just we'll call one of them. See the elevation azimuth, they're identical. Anyways, what I had before was the data would come in, and a certain piece of this data, which I'll show here shortly, would be selected. And what it did before was just turn on this transistor, just a normal switch to ground, and then a wire would go all the way out to the dish, 200 feet away, and that would activate the high speed. So I just simply did the same thing for the nudge on and nudge direction for this pulse nudging or, slight increment I want to be able to adjust the dish position with. I found out, I realized earlier that this simple transistor switching all that way on that wire, that distance, wouldn't always activate. It's just too much wire there. So I did eventually use relays in this also. So this is how it works. The next part, so this is where the bit bashing starts. That number there is what the typical serial data looks like coming into these two picks, these buffer picks. The $5 indicates that following it is the information or data needed for the elevation control. A little farther down, you'll see another sign, $6. This is indicating what's following next is azimuth. These two picks in the code, they sit there and wait and look for either $5 or $6, depending which pick it is. If it's $5, it accepts the next piece of data so many numbers after. So if it's the azimuth, it looks for the $6 and selects so many numbers or bits of data after. In this case, it'd be 1, 2, 3, 4, 5 numbers next. So that's how it distinguishes what is going to be used for, elevation or azimuth. So in the little pick code, now this is established what it's going to do for azimuth or elevation. It picks out the next number. In this case, we'll see as the number 3. And this is telling what the external outputs on this little pick is going to do. Number 1 is high speed on, number 2 is high speed off, number 3 is nudge control motor on, and number 4 is nudge control motor direction. And that's all it does. So depending on what it picks out of the data is what, in a previous picture, which leg is going to do what on the output. After that single number pick out, the next group of 4 digits is the elevation data. And it's pretty straightforward. In this case, it's 0250, or it'll be stripped off and sent on to the next pick main controller as 250. Put a decimal in there, and we have 25 degrees. The azimuth is the same way. It shows here 1035. It'll be converted to 103.5 degrees. And that's all there is. So I had it all figured out. So now was the fun part, was getting rid of the evaluation board I was using for those small picks with that extension plug-in cable, and actually getting the small 12F675 pick itself programmed and in circuit and working by itself. I had a couple of voltmeters tied onto the circuitry to test things, and away we went. That little pick there marked D5, that's the buffer pick that's doing all the fun stuff. So before I go into the final part of this simulation testing, I wanted to show you the disk drive again that I'll be using eventually for the offset feed. It's the 501 gearbox. You can see the incremental encoder that's mounted on there, and it's chained over to the main drive shaft. On the output shaft there, I've bolted on a piece of aluminum, just some scrap junk, and it has a tab there for the home proximity switch. It's just there to show me that this thing's moving up and down. Looking at the shaft is kind of tough. But I do have a small, quite a high-powered laser pointer taped to the end of it. And this is what I project against the wall to really see the small increments move up and down or back and forth sort of thing. Okay, here's the end result of my updated or upgraded dish controller. I'm still using Visual Basic 6. I know people are going to scoff at me saying, why don't you get with the 21st century? Well, I'm too old for anything new, and I'm comfortable with Visual Basic 6. It works. So far, I still got computers old enough to run the darn thing, so until that day happens, I'll keep doing it. So this is the beginning of it. Of course, you can see elevation over here is reading 12.9. That's coming from the encoder. So first I'll hit the setup button. And if I swing over here, you can see what popped up for the setup. Now, this is totally different from what I had before. I have separate, well, we'll call it adjustments. We have the high-speed on-off part. What I usually do is turn that on. And this new rotor is so fast that it takes a long time for it to slow down, so I like setting this around 15 degrees. This is where when it's in high speed, it gets within 15 degrees of its target. It'll switch out of high speed and go down to medium, and then eventually to slow speed. These are all for setting up stop buttons. Again, 10-degree increments, or I could move them up and down or whatever I want, sort of thing. Elevation got for 15 here. That's a bit high. I'll put it down to 10 also. And then Nova Engage, I click on that, and Nova is running in the background, and it connects the moon or sun data through a DDE connection. So anyways, okay, go back to the main screen now, and go back here, and things are kind of running here a bit. So what I'll do is, first off, is I'll just make things move here a bit. You can see Nova is sitting at 19.9. Well, I'm going to do it manually for now. So I take my mouse here and I'll move it up to, go up to 40 degrees. And you hear the motor. She's going at what I call high speed, and once she gets within 15 degrees of the target, there, she switched out, and you hear it slowing down. It's medium speed. And when it gets within 2 degrees, there we go, switches down to slow speed and creeps up to it. Otherwise, it would shoot right past it. And then it sits there and goes crazy trying to figure out which way you got to go. It'll actually stop it and go back. Just so you can see what's happening there. We'll go here with this. All right. I don't know if you can see that there. I'll bump it up. I'll bump it up some more here. We'll go up here. Oh, let's go to 60 degrees. And you can see the motor's turning and see the arm moving up. Yeah, so it comes to a halt. Now, if we go back to the main screen here again, the biggest feature I put into this thing now is, before I had increments, I can go up a 1 degree increments. It just slowly goes up there, you'll see it moving. 0.6, 0.7, 0.8, 0.9, and finally 1 degree. So the desired is equal to the elevation now, or I can go in 0.1 degree. What I've added is this 0.01, and it's you'll see it move, but it's not tracking. I'm just bumping it. I'm just pulsing it. And to really see this work, first off, let me move this down, get down to a lower spot here on a 15 liter. Now this bumping or nudging, I call it, is very small. Like it's less than 0.1. I got it kind of timed in increments of tenths of a 0.1 of a degree. That's how I'm shooting for. So in other words, you can barely see this. You can sort of see the motor move. I'll show you that here when we get to the destination. Slowly sneak in there. Now, I'm going to try to move the camera here. Hopefully it won't make a mess of things. I'll go down to the motor shaft. The motor shaft is right here. So when I move this thing at 0.1 degree, maybe I can zoom in a bit. That'd be the motor shaft. Here's 0.1 of a degree. You can see how much it moves. I guess focused on it. There, I'm moving up to 2.1. There's another 0.1. Now, when I nudge this, I don't know if you're going to be able to see it move or not. Moving in just increments. So in order to really see things happening here, what I've done is on the end of the arm, I have a laser. And I turn this on and get it somewhere where I can see it. Actually, let's bring it down farther here. And you can see the on the far wall. There's the laser. And there, it's coming to a halt. Now I'll just move it over a bit. I'll just turn the motor a bit. Still crawling down. It's not destinated yet. There we go. Now if here's a 0.1 degree movement. There's another 0.1 degree movement. So you can see it barely moves now. On this smaller nudging effect, you can see it move. I'm doing it here. There's another nudge there, another nudge there. So I'm really moving in small increments, slowly getting to that frame. I don't know if I can zoom in on that or not. Let's try this. Oop, sorry about that. There. Now I'll nudge it again. See, I'm barely moving it, so I could have a real fine adjustment on the motors. Or, what else I could do, let's zoom this back out to 1 again. I swing back over to the setup screen. Is that I go into the auto pulse. Right now I'll just do that with the push buttons on the front here, on this part here. I was just nudging these. These are the new nudge controls. They're 0.01 degree, I call them. They're, who knows what they are exactly, but they're small. And if I go over to the setup now, and I go up here and it tells me, right, high speed is still engaged and all that, but if I go to auto pulse up, it turns the high speed off. Also tells me to switch the pick controller to manual, because it will try and track and it doesn't work, because that part of it isn't tied into the tracking system. The encoder doesn't see that small change. So that on, so I'm gonna, I got it right now, got it set for 7 seconds, 7,000 milliseconds. We'll just move this down to, down to 2, just so you can see things happen. Now, swing around again. You can see on the controller there, way over there, you'll see a red light flash somewhere. There it goes. Maybe let me just increase this down some more. Oops, that's a bit much. There's every 1 second. You can see it there. I'll see if I can zoom in a bit. There we go. It's going up and down. Let's slow this up a little bit. There, 0.2. Anyways, now it is bumping the arm. Let's go back up to the laser. Zoom in a bit. Yeah, it's nudging it all by itself. You can slowly see creeping up that picture frame. If I decrease the time down to 1 second, every 1 second it'll get nudged. So I don't know if it's going to be handy or not, but it's some way I could want to track something completely at the timing, and it should track along, whereas before on higher bands 0.1 of a degree was too coarse. So this way I can maybe just have it track that way. It's an experiment. Let's face it, it's just to be an experiment. So I'll go back over here again and I'll turn that off. Turns out there's a pulse up, and there's like a pulse up and a pulse down, so I can go both directions, and they're all set by the timing here and all that. So I turned it off. I'll turn my high speed back on again, and I'm going to turn the pick control back onto automatic, and then I'm back to running things manually. Or Nova's in line. I can go down here and hit auto control. Right now Nova's taking over. Nova went over this on 19.5. This 7 is the nudge. It really doesn't have an effect. It's just there for reference. And so right now I'm tracking, I think it's the sun, and up it goes. So now we're desired to 19.5, and we got 19.5. If I want an offset in here, I can go 0.12 degrees offset, or down this way in that offset, or I can go 1.2, whatever have you. Or if I want to zero it out, so and so. So it works. Seems to, anyways. There's still the, if I go over to the setup screen, I still do have the Where's how this for storing? This will store all these stop increments and the offset values I put in on the auto tracking. The dish status still brings up this screen, which shows me what's going on at the dish, but it's not hooked to nothing. As you can see, no data incoming. So I've already had that hooked up. It works. I copied a lot of this from the other program. So anyways, so far so good. It looks like it's doing its thing. And next step now is I'm going to get the slew gear hooked up, because I know I got to do some work to it. So that's it for this part. Well, I did a bunch of other things to it and worked out some more bugs, but it's finally time to get this hooked up to the big dish outside, which meant to modify the control shelf. Okay, here comes the fun part. We've got to pull that dish controller out of there. And this is what's involved. I've already pulled the bench forward. I've learned over the years that you have to have a movable radio bench so you can get in behind and get at this stuff. Sorry for the jerky video, but still narrow back here to walk around in. Anyways, this is where we're coming up to. Well, actually, I'm going to go buy it and come back in again at it. So, just be patient with me. Here we go. So, that's the back of the computer. Runs Nova and takes the Visual Basic data for it all. And then this is the shelf here that I've got to pull, is that one right there of all the lovely wires connected to that terminal strip back and forth. And all that's got to come off. This is the shelf for the HF antennas, I think it is. Yeah. And this one down here is for my satellite antenna, which I never use anymore. And looking down here, we've got the Shack 12-volt power supply. It's a analog, which I like, but it's a power. It's the one that charges the battery and it gets 12 volts for the whole shack here. And then there's backup power, got an inverter, a pure sine wave inverter, and then this is a DC distribution panel that feeds all the 12 volts bus out to the rest of the equipment. There's a series of fuses in there on the front panel, actually, that breakers actually that protect everything. So that's the scoop. So all I've got to start now is start yanking all these lovely wires off and get things yanked out. So that's the story on that. So head back out of here again. If I can get by all the cables and all the good stuff. Tripping on the wires on my feet. And we're back out again. Well, that's the mess. So that's it for now, for that part. Okay. Now we get the fun of pull the shelf. I got all the wires off, so this is the next step. I don't have any slides in this one. I gotta be careful it doesn't drop into the lower shelf. So, there we go. And out it comes. Easy peasy. So, then on to the modifications. So, I've got the shelf out of the rack and onto the bench. This is what it looks like inside. It's pretty straightforward. What I'm going to be dealing with are the two circuit boards at the top. A little perf board in the middle. Lower down is the RS-232 splitter. Takes in the data in and then splits it into, I think it's 8 different outputs for different reasons, different purposes. A closer look at the two boards that I'm going to be working on. The little 8-pin chip at the top with number 5 marked on it. That's the pick we're going to have to deal with. It's the buffer chip, I've been calling it. And this for elevation. The other one's the azimuth board, and it's marked 6, and that's the buffer that's got to be modified on that board. So not too much. Yeah, once I got the board pulled upside down, I realized I had to move a jumper and this and that, so it wasn't too big of a deal. Got it all modified and then installed the relay boards on special little metal brackets or plates to hold them above. There are the 3 relays for both sides, one for the high speed and then the two each for the nudge control. And something I've been wanting to do for a long time, just waiting for an excuse to have this thing pull off out of the rack, was extend the back plate up so I could get some more DB9 connectors in there for different things. For a longest time, they've just been kind of hanging on wires, so kind of cleaned it up. So this is a test. Here's our control shelf sitting there, already glowing, and I have 2 voltmeters connected to it. They're monitoring the high-speed control relays. I have an encoder there. That's for the azimuth side. Right now I can only test one side at a time, so I'm hooked up to the elevation part of it all. Let's see. So it all goes from there and over to this board in this section right here. This section is the pulse width modulation drive, just the one half of it that's glowing, that LCD display there. I don't need the other half over there because it's the control circuit which I'm testing on the original shelf. So this is my simulator, but I need that pulse width modulation control for the motors. And from that, we swing over to the screen over there, which I'll get closer later. But that's the new Visual Basic program that I've been working on for this new section of it all. So I had about a 20-minute video here of doing this same test, all that I did before, same thing you've seen earlier, and I just couldn't see any point of showing the same thing over and over again. So it tested out good. Had a few more bugs to work out, but all in all, it came together, and it was time to put her back in the rack. So it slid back in, and then there was the fun part of going back there and getting all those wires sorted out and put back together. It went together. It wasn't that bad. Everything's numbered and labeled, so just a little bit of time. Well, since the control shelf had been powered down and yanked out, put back in again, the dish positioning was, well, all out of whack, so I had to recalibrate it. So, beautiful day here today, and so I'm swinging the dish around to get it over close to where the 0 home positioning is, so the calibration procedure inside will, process it rather quickly. I swing it all the way around and then lower the elevation until they both find their home positions on the proximity switches. Then I raise them up and go forward a little bit just so that the circuitry inside can take over with a little bit of room. Okay, here we go. We're going to let the dish do its calibration mode to get everything at home or 0 degrees. So you can see over here in the left-hand screen is where I positioned it earlier manually outside to get it close to home. I don't like having to go a long ways just in case something happens. So I'll go back over to here. Right about there somewhere. And if everything's working right, on the left-hand screen on the right-hand side you can see azimuth there. It'll do a random count just as it's doing its advancement up from 0 home. It finds 0 home. So to get into calibration mode, I got to hold the stop button down, hit the reset. There's rebooting, and it'll go into another section, starting calibration number 1. And you can see on the azimuth up on the screen there, I don't know if you can see it, it's probably too small, but it's saying 485. It's just a number. It's going to count down. The green light came on here telling me the home switch, the proximity switch, has been activated. So it'll stop turning there. It'll beep, drive home 0, calibration number 5, or has been found. So now it's going to advance up 5 degrees. This is a kind of a dual process I put in this controller back when I was using the my 10-foot and 12-foot dish, and it had a real sloppy drive, and the wind would blow it around. And this was just a get it home, go up a little bit, and come back real slow to find the home spot. So it's here we're at 4, 4.3, 4.5, 4.7. There it's found 5 degrees. It stops. Now it's going to go back to home real slow. And at that point, it'll reset everything to 0. It says here starting drive calibration number 2. I like watching it on the VB screen there just to tell things are working. There's our current azimuth motor, 100.1 of an amp. Yeah, it's going downhill. Or, I mean, the big Sluger doesn't take much. There it's found calibration number 2. Drive home 0, and it should go to 0. We're close to it. Complete here, 0, and there it is. Up here, 0 degrees here, and 0 degrees here. The home switch is still on because it's at home. So we'll do the elevation next. I'm just going to swing it about over here a little bit. You can watch it on the screen maybe if you can see it. I don't know if you'll see it. I do the same process. Hit the hold stop button down. Hit the reset. Just rebooting. All right, starting drive calibration number 1. No, it's slowly going down. I had to raise a little bit, so again, random count up here, just a count to see where it's going. The elevation, the home switch light on the PIC panel has come on, so it's stopped. There's the beep saying it's found calibration point number 1. Now it's going to zero it. Now it's going to go up 5 degrees. What are we drawing for current? Oh, 800 milliamps. So far, so good. You can see on the I don't know if on the status screen over, you can see some warnings over here. This one is saying elevation low speed engaged and azimuth home switch activated because it's still at home. So it's that part's working on this new screen. There, it's found home. Well, I mean, sorry, it went up 5 degrees. Now it's going to start going down. At this point, it's supposed to find the proximity switch again for the home position, but it also, there's a block of wood up there, and it's very tight. So sometimes a bit of a struggle between the two. But it's right at 0 degrees anyway, so it's close enough. When I'm tracking things, I use the offset to accurately get things pointing. This gives us a relative indication where we're at, gives us a good idea. Should be pretty close to being there. There's, yep, 0 degrees, it's right on. So our light came on the panel over here. And our home switch is on the elevation, home switch is on the azimuth. Drive home, drive complete. So it's everything's 0 and 0. So it's looking good, that part. So she's calibrated. That's the first test I wanted to do, because I did change a few things in the PIC code. So yeah, I thought I'd zoom in a little closer here so you can see things better. You can see on the status screen both our home switches have been activated, so it's at 0 degrees on both positions. Okay, we'll swing down here, setup screen, and I'm going to turn on, find my mouse, here we go. Turn on a high speed enable on both them. I'm going to leave them at 10 degrees. And I haven't got Nova engaged, but that's okay. I'm not going to use it. So now we'll swing over to here. And we'll see how she works the elevation. I'm going to take my mouse. I'm going to go up to, I'll go 20 degrees. There's 20 degrees. So, oh, got to put an automatic mode here. There we go. Forgot to do that. She's in high speed. She appears to be lifting. You can see it in there. Also over in this screen here, things are telling me good things here. It's Elevation's going up. We've got elevation, high speed engaged. The azimuth home switch is still activated because I'm only activating elevation. So it's getting there. There, she's within 10 degrees. High speed went off. I'll go back over to here. Medium speed's been engaged according to the status screen. And we'll get within, I think it's 2 degrees. She'll go into slow mode. And you can see in the camera it's slowly creeping up. There. Yeah. Elevation low speed's been engaged according to the status screen. Slowly getting there. There we go. 20 degrees, motor's off. Good. Okay, that's the elevation. Now we'll move the azimuth around. Take our mouse. And I'm going to go for 90 degrees. Oh, let's see. 89. That's how. 91's good. 92, 90. 91's close enough. High speed's engaged. Again, you can go over to the status screen here, and he's telling me azimuth high speed's engaged. We're sucking about 400 milliamps on the azimuth motor at the top there. Well, didn't get up there high enough, but you'll see it. That's not that important. This is the good stuff here. You can see in the camera she's swinging around. Somebody's making noises upstairs. Beautiful day today. Last couple of days have been 18 below. I'll just show you something here while we're waiting for this to come around. We're still in high speed mode, so we got time. But external temperature right now is 6.5 degrees plus centigrade. Inside the enclosure and the door is open, it's 10.5. So it's a beautiful day, good day for testing this thing. I didn't want to do it in 20 below weather. Yeah, no, he's so still. Coming around, what am I going to? 80? 91 degrees desired. We're going to get within 10 degrees. So 81, oh, yeah. 81 degrees, it'll switch out of high speed. I could probably lower that a lot in the setup screen, but good enough for now. I'm just want to test this function of the new Visual Basic screen. Getting close. High speed will be kicking out pretty soon. Another couple degrees. There we go. High speed's out. Switch to the medium speed. You don't see a whole lot of difference, but it is slowing down. And where am I going? Oh, yeah, 91 degrees, so we're almost there. I think what I'm going to do, I want to swing this thing right around the 180 once it gets stopped here. But I'll do that off camera. No sense boring you people too much in this. I'll just test a few more things here while we're at it. Okay. Oh, we'll check out the 1 degree increment. Up to 92 degrees. That second digit is, because of the fraction of figuring out the slew gear, it's always off a little bit. The over here in the pick display, it's right on the money. 92, yeah, 92.1. That's typical. Let's go 1 degree increment. Yeah. That's interesting. 92.3, 92.3. There might be something there I'll got to look at. Another increment. Oh no, that's 0.1 degree increment. Yeah, 0.49, 0.5. Yep, I'm okay. I can't even remember how to write my own stuff here. Let's go down a degree. 914.915. Yeah. Okay, let's go over and check out the elevation. We'll go up a degree. This is dead on the money because of the non-fractional division and the code math to get the loop oh boy, I'm trying to say the loop calculation. It's not like the slew gear. Slew gear is a bit of a mess that way, but it works. It's hard to get around it because it wasn't a proper division. Had to contend with a fraction, so it's a little off. Good, looks good. Yeah, 91 down, go down to 0.1 of a degree, yeah, right on the money. Yeah. That part really works well. So far so good. Okay, we're on to the next test. This is the nudge control, the new feature. We'll see how this is going to work. So first off, we'll see that I'm going to be playing with the elevation, and hear the relay click. And you can see this, the 7 is just a, how can I describe it? Just a relative indicator that things are moving. But it'll go up, same with the 8 here. But when we go up enough that count gets over to it, we'll get, there's 19.6, so it tells me it's moving. Also though, the feature's trying to automatically move it back and forth. I can also go over to the status screen if I can zoom in and make us see something here. I'm going to have to move back just a touch. So you're going to see the elevation current are clicking, and it'll show up here that things are happening. This is the status screen that comes from the outside. So I go over here again, 0.01, we'll take this off. And there, it's elevation, medium speed came on real quick, and you can see the current jolt up there at the elevation motor. So it's telling me something is happening out there. And down. Yeah. Okay, so another way we're going to prove this is by doing this. Let's go back out here again. Go back over here to the camera. Now, let's move the... Sorry for the unsteadiness of everything here. We're going to move over to the camera lens. We'll swing in a bit. Now, I got two cameras out there. This is the low light one. If I switch over to the telescopic one, it's not as clear, but I can do this. We can look at the end of the feed horn, or the feed mount. Watch it against the trees. So I'm going to do two things here. Put this back in automatic mode. Now, just to see the difference, we're going to click. Here's a 1 degree movement. See how much it moves. Gives us an idea. Quite a ways. That's 1 degree. Up 1 degree. And this is 0.1 degree. Not much, other than the bouncing. I'll hit the 0.1 again. Okay, gives you an idea how far it moves. Now I'll do the nudge. There. Again. And one more time. So it is moving in very small increments compared to the 0.1. I'll go down. Here's down 0.1 degree again. Yeah, it's 0.1, yeah. So here's down, we'll call it the nudge, or I could call it 0.01. So it is doing the thing I want it to do, going very small increments. So, okay, that's telling us something. Now, if I shrink this out again here, let's go over to the setup screen. And what I'm going to do here now is the automatic feature. So let's go over to we'll turn the auto pulse off. We'll go on. Auto pulse on. I already got it set for 3 seconds. Telling me to turn the manual mode. I do. So it's clicking automatically. So let's go back over to the camera. So it's showing it going up in small increments. Of course, that's every 3 seconds. I got it going fast so we can see it moving. I can slow it right down too, any time I really want. So, seems to work. This part, anyways. Got some more things to show you. So, that's it for now on this part. Okay, this is a pretty curious part I want to see is what the difference in the encoder wheel here. When I go from, say, 0.1 to the nudge, or 0.01 roughly. So I got the camera set up outside here. We'll zoom in. Should be good there. Now I got to go all the way back inside because I can't activate it from out here. So I'll be back shortly, or you'll be seeing things move here, and then I'll talk about it later. Well, I'm hoping to get this all synced together. The first rotation here would be a movement of 1 degree. The next, I moved it forward 0.1. That's 0.1 of a degree a couple of times. Then finally, I got it onto the one we're looking for, the nudge, or 0.01 degree roughly movement. That was me hitting the nudge button on the screen. Then I stuck it in auto nudge control. I think I had it set for 3 seconds. I had a bunch of other things a little later, but this is just taking too long, so we'll cut it short. Okay, we're looking at the elevation motor and the Lovejoy connector. That's about the only thing you can really see move. So again, I'll go back inside and start moving things. Again, this is a 1 degree total movement. And this is just like before, the 0.1 degree movement. I think I did it twice. Then as before, I moved it in the nudge position, or 0.01 degree, 4 times, I think it was. So, wow. If you've been here still all this length of time, you must be bored. Oh boy, this has been taking a long time. Anyways, it looks like it works. The test on the big dish itself seems to have panned out, so I'm tickled pink. So, we'll find out. There's a 6 centimeter event coming up here in a few weeks, and we'll be able to see how well I can peak on the moon noise. But until then, that's it. So thanks for watching if you made it this far. It's a long one, good grief. Anyways, 73 from Skip. Victor Echo 6, Bravo, Golf Tango.